questions. And now the recording is on. So I will collect all the questions, and we will have a Q&A session at the end of this talk where I pass the questions on to the guys at Qualisys. Note that you should use the chat in this room, the one at the bottom of the screen. I also just want to let you know that after the talk, we will continue in the Mybo rooms, where you can talk to the guys at Qualisys or to us at BitCraze and maybe discuss specific questions or other details. So that's more of a one-on-one type of discussions. Excellent. So now to the talk. Qualisys is also a Swedish company. They are making high-end motion capture systems. We have a lot of similarities between the companies, and they are located in Gothenburg, not too far away from us. So we are very happy to have a collaboration with them, and we're trying to improve how drones and motion capture systems work together. There has been a slight change in the speaker lineup, but here Martin Holmberg is still speaking, but Magnus, there's now another Magnus Berlander. So welcome, guys. The stage is yours.
Thank you very much, Christopher. First off, we're going to run this presentation in video mode with no kind of desktop sharing. So if you go down to the bottom, there's a grid function. And if you press that one and then you press our video, then you will get us up in full screen if you only have a small window. Else it will be hard to see our PowerPoints. As Christopher said, I got the company by Magnus Berlander, who's our product manager for engineering and also our CTO. He's very down into the nitty-gritty details of our tech. And I'm product manager entertainment, but I do have a big passion for drones. It was actually my master thesis I did back in the day here at Qualisys, tracking drones with mocap system. We have been working with BitCraze for about, I think it's 7 or 8 years ago. I first came in contact and had a chat with Christopher, and then we started doing collaborative work on some of the products we're going to show. We went to exhibitions together and so on. It's been a pleasure. It's one of my favorite companies to work together with, and it's always nice to get the opportunity to go down to Malmö and eat falafel and just enjoy the southern parts of Sweden. A fun thing is I got this on Facebook today, where Facebook said, you have a memory for 3 years ago. BitCraze was visiting us, and we got the opportunity to fly a bit of swarms. We got the opportunity to do what you always do when you fly drones, and you crash a bit. And this is one of the things that I enjoy with the BitCraze and working with it. The fact that you can test and you can try out. You don't have to have a net. It's so durable. And it's so easy to repair also. So it was just this nice memory to wake up to. And, I'm going to talk on the BAM days. And yeah, I'm really stoked. Now Magnus is going to talk a bit more.
A bit. Thank you. Yeah, when you do changes in the presenters, don't make them too big. So swap a Magnus to another Magnus. That's a good way. I will just talk a bit about our technology, some of the gadgets and tools that makes this all possible. I will show some cool use cases as well. So starting off in the center today is BitCraze with the Crazy Flies, and to the upper left you see the 2 cameras that we at Qualisys use to track drones and to track humans, to track basically everything that you can attach markers to. To the upper right you have some of the tracking targets. We're going to focus on active tracking today, but we do passive tracking as well with reflective markers. The bottom left shows a bit of the ecosystem that we operate in. So we take pride in making our system accessible and usable in as many use cases as possible, together with as many third-party softwares as possible. So with that said, let's kick this off with a couple of examples. This one is a nice show of a standard setup in some aspects, but different in others. So this is University of Oslo, and they have a 3-volume mock-up system. So you have 2 rooms indoors. They are separated by the pillars you see. But what is quite unique is that they also extend the volume outdoors. So towards the end of this short clip, you will see the drone approaching the window slowly, making its way out. And on the bottom right, you see a footage from outside of their lab. So this allows them to do some experiments that's a bit unique. And this is thanks to the outdoor capabilities of the Qualisys system. So it survives outdoor weather, and it can operate in the bright light that you may have. Another really cool installation is this one. This is from Purdue University in the US. It's the largest indoor motion capture arena for drones that we know of. They house it in an old aircraft hangar. And the reason for them to do this is that they're looking to track fixed-wing aircrafts indoors. So the volume is something like 60 by 30 meters. And you see on the bottom right, or on the right side, you have an image on the volume. It's something like 8 and 10 meters up to the cameras. What is so cool is that the video you're watching now shows crazy flies being tracked. So we managed to equip them with a volume that allows them to do fixed-wing aircrafts over 60 by 30 meter volume. At the same time, they can track the small crazy flies in the center of the volume to do nice, well, things like what you're watching here. And they've got great ambition to add more drones to the mix. Just showing you what this can look like. This is a view from Qualisys Track Manager. It's the Qualisys tracking software that you as an operator interact with. The video shows 6 drones being tracked. So these drones, they are equipped with the active deck that we will look closer at shortly. And when zooming out now, you kind of get an appreciation for the scale and the size of that volume. So the crazy flies are really small and tiny in this volume, but we're still able to track them at the same time as we can cover the whole 60 by 30 meter volume. So it's a very nice and impressive facility, and a lot of cool research will come out of that group's work, I'm sure. I will round off this small session with a movie from Chalmers University. It's local to us here in Gothenburg, and it's from a research group focusing on human-drone interaction. In this movie, you will see some of the devices and some of the props that I have in front of me here, and we'll go through later today. And I will let the presenters do the talking. So enjoy this minute and a half.
Recording a robot's movement and analyzing it are not the only things you can do with the Qualisys cameras. I'm very excited about the ability to track several different kinds of robots and to stream control signals to them in real time, so we can track robots and drones and props as well as the human body in the same calibrated coordinate system and build experiences with movement, controlling, and in a way collaborating with these robots.
Uniting the physical and digital worlds is the holy grail of human-computer interaction. We're grateful to Qualisys for one of the most versatile tools to accomplish this and actively supporting and collaborating with researchers like us.
Nice. So from this, let's dive straight into the tech. I grabbed 2 images from Bitcrate's website showing their kind of mocap related offerings. So they do have the motion capture deck, which is for passive marker. It's a PCB with holes in it that makes it easy to attach passive markers. They also have the active marker deck, which is a unique cooperation together with us here at Qualisys, where they developed a tracking deck based off of our proprietary active tracking technologies and made it available to all Crazy Flies users out there. What makes that unique is the fact that you can get full 6-DoF orientation and position data. So 3 degrees of freedom position-wise, 3 degrees of freedom orientation-wise. And you can do this with a lot of drones. We'll look into that shortly. The same kind of active technology is used in some of our products. This is the active tracker. It's a packaged tracker with 4 markers that you can attach to objects. And it allows you to track objects on a very large distance. And, well, a lot of them at the same time. We do have an unpackaged version. We call it the naked tracker. It's meant to be embedded into objects, making the sort of tracking capabilities of the object as hidden as possible. And lastly, we have the Bitcrate's active deck. So all of these products use the same active tracking technologies. It works together with our cameras and the QTM software in the same way. Looking closer at the naked tracker, it's comprised of a PCB with, well, a marker processor and the tracking technology built into it. It comes with 8 LEDs. So, for example, if you have a large device that you may not see from all sides at the same time, you can have 8 markers kind of all around the surface of it. It also comes with an IR detector, and this is one of the unique aspects of this system, is that it uses optical means to synchronize the cameras with objects. And this is great in the sense that it's not affected by radio interference. So, for example, you can use it when you have a lot of Wi-Fi networks, and other kind of networks, and it's sort of not affected by that. So then, why active, you may ask? And there are a couple of reasons. So one is identification. If you're used to optical tracking system, most of them use passive markers, which have a lot of advantages. You can easily attach them with double adhesive tape. They're lightweight, they don't require to be charged. But if you're tracking objects, especially if you want 6 degrees of freedom, you need 3, 4, 5 markers on the object. And if you have a lot of objects, it can be hard to create geometrically different patterns, which is required to kind of separate one object from another. Using active technologies, this is not necessary because we use sequence coding instead. So each marker is associated with an ID. So you can separate one marker from another. And with our system, we can track about 185 objects, each with 4 markers on them, at frequencies up to 500 frames per second. The last one is depending on the camera model that you use. And embedding LEDs makes it possible to kind of hide the tracking capabilities of the objects. What's not listed here is range. So usually you also get added distance from cameras to objects if you go with active technologies. But still, passive has a lot of upsides as well. So it all depends on the use case. With that said, let's take a look at the objects. So if we can get the full video, then let's swap to the other camera. Thank you. This is what the active tracker looks like. As you can see, it's not very big. Too big to be carried by a crazy fly though, but still. This is what the, let's see if I can put that in a way so you see, this is what the active deck looks like. It might be hard to see, but it's basically 4 LEDs together with a microcontroller and IR receiver. This is what the naked tracker can look like when once embedded into an object. The whole point is that you're not supposed to see it, but if you look close, there are some black dots on the chassis. So these are LEDs that are integrated into the chassis. So this one is tracked by our system. And to kind of stick with the theme of today, sorry about this, it's a DJI drone, but we wanted to mount the naked tracker onto something that we can fly. So let's see if we can show you what this looks like in the software. You have 4 LEDs on this one together with a naked tracker PCB. So let's see if I'm able to turn this on. And now we're going to swap to the QTM software. So you can see what this looks like in QTM. And there we go. So I hope you're able to see the small coordinate system moving in the QTM's 3D world. And if we perhaps can enlarge the QTM screen, you see three coordinate systems. The one in the middle represents the global coordinate system of the volume. The 2 others represent the 3 objects that we have in the volume. One is a landing pad. We will use that later on with passive markers. And the other one is the DJI drone that we just flew, and now we just picked this one up. So this is what the data looks like in QTM. Right, with that said, I'm handing over to you, Martin.
Yeah, thank you very much. There we go. And now you can hear me also. Cool. So just a few words about some of our of our software parts. So if we get a bit of PowerPoint here, QTM, that's our main software. It's the software that communicates with the camera. It takes 2D coordinates from the cameras, creates 3D data from that. If the bodies or if the markers are rigid in relationship, it creates 6 stuff out of it, and it contains all the visualization parts. For a drone use case, the most important part is probably that it streams this over UDP, but you can of course use TCP also, but yeah, would recommend UDP. Going for a bit of unique selling points, which you always have to throw in there. One of the big things, so it's a small thing, but we're proud of it. We do site licenses. We don't want to work with dongles and 1 license per person. So this is good for research laboratories. It means that each student can have their own license or use the school's license to bring it home. We simulate the real time, which means that you can do your development at home. You don't have to be in the lab just to get data to see what, if you do decision making and so on. It's quite nice. So streaming, which is probably what most of you would be doing, real time. Real time for us is somewhere about 3.5 to 4.5 milliseconds of latency. It's mostly from the cameras and the time it takes to read the data from the sensor. So faster cameras, lower latency. And then processing time is somewhere between 0.5 to 1 millisecond inside of our software. So that's what you can expect. We do streaming to most things. Of course, we have the plugins for MATLAB, LabVIEW. We have integrations with ROS, actually written by our customers. Big thank you to KTH there for adopting the ROS packages. We do open source SDKs. I'm going to talk a little bit more about that later, but C++, C#, Python, Node.js, so JavaScript, and so on. Just want to mention a bit of learnings also, and doing the teaching resources, which is Q Academy for us. We have a huge collection of training videos. We have training videos on how to fly a crazy fly with a Qualisys system. It contains videos, PDFs, and so on. It's available for all our customers. And it's, yeah, just wanted to, if you are a customer and you have missed this, please have a look. If you're not a customer but you're interested, just shoot us an email afterwards so that you can have access to it and see how to run the system. Now I'm just going to jump over to the presentation computer and talk a little bit about our GitHub, because we actually filled that one with all our open source projects. We believe that everything that is outside of our core technology, the tracker, should be open source. We enjoy the collaboration. We do get quite a lot of pull requests. We do our own development here. We have, as I said, SDKs for a bunch of things. And we also have Crazyfly resources. So this is a small repository with directions on how to fly, what settings to use within QTM, and a bunch of examples. And one of the examples that is here is BAM 2021, where Mehmet, as you saw in the video, wrote a small script that is going to demo how to fly. And there is also an intro or a tutorial on how to use this code and how it was written on Mehmet's homepage. There will be a link in the chat, I guess, for it afterwards, or just ask us and we'll get it to you. But now it's actually time for a bit of live demo. So if I jump over here, we have a Crazyfly. We have an active deck. And if you take that and you add on one Chalmers researcher, thank you, Mehmet, for helping us with this. The idea of this is, so the demo will be fly the quadcopter, do a bit of platooning with our Volvo here with the integrated naked tracker, drive that around. The Crazyfly will follow along the car within the safe zone that we have set up, and then it's going to land on the landing plate with a big Q on it. There's a queue. It's hard to see. Do we feel ready? Yeah, cool. And this script is about, what did we say? 600-700 lines? 500 lines. So, I mean, it's not much required to use this. And then the libraries that Bitcray supplies with the cflib for Python, it's so easy to use. It's very easy to get going. So, I mean, this is the kind of experiments that is possible to do very easily. So there we go. And we drive the car around. The Bitcray is trying to fly after it, as long as I don't drive outside, because then, yeah, we have a safe zone. We are keeping the speed down a bit for for demo safety purposes, and then the idea is to land on the landing plate. If I pick this up, will this work? We'll find out. Okay, so this never tried before. So yeah, I mean, being able to do this with a small drone where you can actually do things like, okay, let it fly to me without actually being afraid is, yeah, I think it's so nice. Magnus, do you want to?
Thank you. Do you have a clicker, perhaps?
Oh,
We do have a live tracking system and drones, so why not use them? Thanks a lot, Martin and Mehmet, for the show. Let's see if we can get the PowerPoint in here as well. There we go. So to round off, we wanted to show you what it can look like in a true outdoor setup. So the video that follows is from M-Air. So this is from Michigan in the US. They've equipped a netted place with outdoor Qualisys cameras. So they sit there permanently in the Michigan weather, whether it's hot or cold, rainy or snow. And they use this to do some amazing research. But I will leave that to the presenters, so please enjoy.
It's never been easier to get drones working and flying at this point. Whether the world's ready for it or not, companies are going to start trying to do things with drones.
This facility is called M-Air. It's the netted flight facility that allows us to do all kinds of experiments with flying objects that can't escape. Our goal with the Qualisys motion capture was to have coverage of the entire facility, or at least as much of it as possible, to allow the vehicles to fly with continuous tracking. In aerospace engineering, we study a variety of things ranging from vehicle design and analysis of the structure to control. And control in the large sense involves perception, decision-making, and acting. All of these have to be done in real time in flight, because it can be less than a second before a drone crashes if it makes a poor decision. Any facility that provides comprehensive testing for flight or ground-based robotic systems needs to have truth data. Qualisys can provide that data, and then each user can decide what they want to do with it, either in real time or later after the test concludes. The quality and reliability of the motion capture system are outstanding.
I believe it's down to like a millimeter of accuracy on where the vehicle is, which is not attainable through really any other means. Having that kind of position feedback is invaluable.
Qualisys had the longest proven outdoor option, which had a big influence on our decision.
We look at the weather as a real feature, not a bug here. It had to be able to run in the snow and the rain, ice events.
As long as my hands are warm, I can use the Qualisys system out here.
I think a lot of people who are developing facilities for flight vehicles recognize the need to have a high-quality motion capture system.
Using the information from the Qualisys system, we can automate these vehicles. You take people out of harm's way and you get the job done faster and more efficiently than you could with a person. It's in search and rescue with ski patrol, railroad inspections, wind turbine inspections, different photography applications.
We like to think that the University of Michigan is somewhat in the lead with both having a really nice professional facility constructed and to completely equip it with motion capture. We imagine others will follow us.
Cool. Thank you very much. Thank you everyone for listening. We were a little bit faster than planned. We demoed really quickly, so that's nice. Now I guess that Christopher, were there any nice questions in the chat?
Yes, there's not a lot of questions in the chat, unfortunately. But if anyone has any questions, make sure to ask them now. I have some things that I am curious about. First of all, the outdoor cameras or systems, are those cameras protected in any special way? Or I mean, do you need some sort of boxes around them or anything, or how does it work?
No, you want to grab that?
I can do that. So yeah, one of the camera series, the one called Arcus, they come in sort of natively protected versions. They are rated IP67, so that means that they can withstand a lot of moist. They can actually be lowered into water for a brief period of time, and they also rated to be able to run in higher temperatures than the normal cameras. So they're being used outdoors in some quite demanding situations.
Thank you. We've got a question from Joseph. How does the active marker deck compare to the passive deck in terms of flight time on a single charge?
Oh, that's almost a question for you, I would say. What's the power consumption on that guy? We haven't done any tests. So I would have to hand that over to you, Christopher.
Thank you. I'm looking around here in the office to see if anyone has any good guess. Actually, I don't know myself. I haven't really tested that.
My guess would be that it's quite limited in difference.
Yeah, I think so.
The power consumption of those IR LEDs, I mean, they are LEDs, so they are not very power hungry.
Yeah.
I would assume that the difference would be quite minimal.
And also
my guess is that the weight of the deck might be the having a more effect on the flight time than the LEDs.
Yeah.
Yeah, I have actually another question that your answer, Magnus, was triggering. That you talked about submerging the cameras in water. I know that you have underwater tracking as well, right?
Yeah, that's right. So we recommend special cameras for that purpose.
Okay.
We do have dedicated underwater cameras. They use not IR light for illumination. So IR are very much absorbed by water. Water is usually blue because short wavelengths penetrate water better than long ones. So our underwater cameras are equipped with blue LEDs instead. But like you say, that they're designed for underwater motion capture. So we use them or our customers, I should say, use them to track underwater objects. It can be autonomous vehicles. It can be subs, scale model of subs. It can be to observe windmill towers, for example, or pipelines, sort of going from the ocean bed, crossing the water surface. So tracking a lot of different objects underwater. So we're waiting for that BitCraze underwater drone as well.
Yes, the crazy sub.
Yeah. When is that out?
Can you hear me again? I had some technical problems.
Yeah. Now you're back again.
Good. Yeah, we got a follow-up question on if the naked tracker is too heavy for the Crazy Fly, and I don't know how heavy is the naked tracker.
I don't have the weight in my head, but I would assume that it is, or at least that the active deck is lighter.
Yeah,
and smaller.
It's smaller, and actually, it is possible to cut the arms on the active marker deck and solder cables to it if you want to place the markers at different physical positions than the arms. So it is actually designed for this extra feature. Yes,
Yeah,
maybe sorry, yeah.
Yeah, and also the naked tracker would require more power or higher voltages, so it would probably not run on, maybe run on that battery, but yeah, not for the Crazy Fly, but I'm looking forward on the next generations where it can carry a bit more load.
Yes. Excellent. Maybe one last question. Would it be possible to talk about how much it would cost to get something like this working, to buy a Qualisys system?
Yeah, and I mean that's a question that I really like to get in this situation, because it's often referred to as the expensive option, and I mean that's true compared to a couple of lighthouses and so on, but it's often not as expensive as you would think. So a small system to track, for example, a bunch of bit crazy flies would be somewhere starting 35,000 euros, something like that. So it's not in the 100,000 euro range to start with. Of course, the sky is the limit when you go outside and big rooms and so on. But I would say that it's more reachable than you would think. So one of those rumors that it's nice to talk about.
Yes, thank you. I mean, it's great to sort of have a starting point of an understanding of how much one of these systems might be. Thank you very much. I don't think there are any more questions in the chat, so I would like to thank you very much for your talk. And now we will head over to the Mybo rooms. And as mentioned before, this is the perfect place to have ask questions either to us or to the Qualisys guys, and have more informal discussions. So again, thank you very much, and see you.
Thank you for having us.
Thank you very much.